I am recording this video during the pandemic times, and it's not only COVID-19 which is an issue that is getting much attention from world leaders and from people who have some engineering background. There is a somewhat suppressed issue which is rarely spoken about in mass media. And this has to do with the Three Gorges Dam in Yangtze River in Hubei province in China. This is considered to be one of the great feats of modern engineering. They say that this dam is so huge and the quantity of water it collects is so huge it is affecting the velocity with which our planet is rotating around its axis. Why is this a big issue today which is somewhat suppressed? This is not often spoken about in mass media in the same way that the beginnings of the pandemic, of the virus, of its spread in China was also somewhat suppressed. If the Three Gorges Dam burst, if it breaks apart, it will affect three major cities in China: Wuhan, Nanjing, and Shanghai. These three cities together comprise something like close to 400 million people. That's almost the size of the populations of three countries. That is how big the impact is going to be when the dam bursts and when the water floods the big cities in eastern China. Those three provinces or those three cities were not just home to people. You know China now. China is a major economic power. And those three cities are big commercial hubs. So if those cities were flooded, it's not only the local community which is going to be impacted, the world is going to be impacted because of the disruptions in trade and commerce. So I am showing to you these slides because this has a math content. The dam, the issue surrounding the dam has a math content, and those issues have important repercussions to the community that will be impacted by the dam when the dam bursts. So this is one issue that if you were a civil engineer would have to find answers to. What is the volume of water in the reservoir that will put the dam in critical point? The point before the dam burst. The issues the civil engineer will have to pay attention to would be water, the quantity of water coming from the rain, the quantity of water that is flowing into the dam, coming from the different rivers that feed water into the Yangtze River. We also have the silt, the issue about the silt, the quantity of silt, the quantity of debris that is carried by water into the dam. That also impacts the structure of the dam. We also have the velocity of water. So this is a problem with math content. And so engineers have to find answers for this. I also had the chance to work on a problem which has a significance outside the classroom. And this has to do with climate change and the rising sea levels. I presented the results of my paper in the International Conference on Disasters in Asia. This was in 2015. It was organized by the Asia Center, University of the Philippines. I was the speaker for the first day, and the title of my paper was Coastal Land versus Sea Level Rise, a Land Inundation Model for Small Communities. So this is a problem with math content, and I wanted to give answers, to produce a model using what I know and my skills so that a local community would know how sea level rise will impact their community. So this one is actually a picture, an aerial picture of a place in Manila, Batangas, where I used to swim. I used to be an athlete. I was a triathlete of so many years, 15 years. And I was always here, swimming, and running. I was running here. If sea level would rise, and it is rising at around 3.1 1 centimeters a year, how will that impact the coastal villages near the beach? So someday in the future, if the sea level will continue to rise, a part of this beach will be underwater. So this is my initial strategy. I compared. So this piece of land, each point there has an elevation. In fact, many phones have an apps that will tell you your elevation in relation to the sea level. So that information can appear something like this. So close to the beach, this means you could be something like 1 centimeter above sea level. And when you are here, that information, that data there, or that number there says you are 5 centimeters above sea level. So what's going to happen is something like this. Given a particular elevation at time t, with the passing of time in years, it's going to decrease. This is the initial elevation above sea level. With the passing of time in years, it's going to decrease. And then at time t in the future, this will be its new elevation. So this is the initial model for each point on the plane. So we can imagine the land area to be somewhat like a matrix. Okay, I don't know if you have heard about the matrix. Well, you can look at the matrix as a table. It has columns, it has rows. Each cell corresponds, or it contains a number. In this case, each cell contains the elevation of that point in relation to sea level. Okay, so this one would be the sea. We shall consider this part of the matrix as containing zeros. This one is 5 centimeters above sea level. This one is 9 centimeters above sea level. So with the passage of time in years, this is what's going to happen. They will decrease in value. So our new interpretation now, after 4 years, is this point, which used to be 9 centimeters above sea level, it's now only 6 centimeters above sea level. And this point, which used to be 3 centimeters above sea level, after 4 years, is now underwater. Or if it's not underwater, it is regularly being impacted by the tides of the water. There is also an issue about the land area. Again, I attacked this problem using what I know. I could have just gone to the internet and used the available technologies there. But I chose to do it using what I know in applied mathematics. So I imagined the masses of lands along the beach to be triangular prisms. Okay, look at that. So it's like a row of uneven triangular prisms. So if I am looking for the area of the land that's going to be impacted by the rising sea level, I will be looking at the area of a plane, of a surface which is actually a surface of the face of a triangular prism. So after working on this, these are the models that I came to produce, and I presented this in that conference. So the reason why I gave that long introduction has to do with our topic today, which is Polya's 4-step strategy for problem solving. When I saw this topic, Polya's 4-step strategy for problem solving, well, I just discovered that, hey, this was how I had been attacking problems with math content in my life as a student, as a math teacher. So it turns out I had been doing this, but I didn't know that someone gave it a name. Polya's 4-step strategy for solving problem, or for problem solving. Understand the problem, devise a plan. Okay, so in my experience, my problem was to see what part of the beach, of the communities will be impacted by rising sea level after the passing of many years. So what part? So it's a geometric problem. I want to see where will the water go after 20 or 50 years. So it's a geometric problem. But you know what? Sometimes the solution, your initial solutions produce results which seem not to be consistent with your expected results in your plan. It's like the result does not match your expectations. So you may have to devise a new plan. Or maybe you understood the problem poorly, or you understood it in the wrong way. So Polya's four-step strategy for problem solving, it is not a straight linear progression in solving a problem. It's not. It is cyclical. You devise a plan, you carry out a plan, you produce a solution, you test the solution. Maybe you got it wrong, so you have to begin again. You have to ask yourself, did you understand the problem correctly? Right now, being a student, the problems that you are working on, problems with math content, are the problems that are contained in your exams. And the significance of this really ends in the classroom, or it ends with you failing the course and you repeating it. But in your examination, when you answer each of these items, let's say, for example, this is a multiple choice type of an exam. If you're the sort of student who finds yourself doing this for each of this problem, it only means one thing. You are not prepared for this exam. You did not study for the exam. Because if you did study for the exam, you are very much well prepared. You don't even have to seriously give this much thought and much time, because as soon as you see it, you already know what to do. That's what happens when a student is very well prepared for an exam. Everything happens automatically. You're like a machine. But somewhere in your examination, your teacher will give you a question where you may have to do this. And so sometimes the teachers will give this not as part of a regular examination. Sometimes they will give this problem as part of a problem set. And your teachers do not expect you to submit it after one day. When I was a student, the problem sets that we had a timetable of 2 weeks. We had 2 weeks to finish them. Okay, so let's say, for example, the problem is something like this. A planet's orbit is described by the equation. Okay, a comet trajectory follows a parabolic path described by this equation. Where in the planet's orbit might the comet hit the planet? All right. Okay, so looking into this problem, this is a curve. This is also a curve. The curve that describes the orbit of the planet. This one is the curve that describes the trajectory of a comet. They have the possibility of crossing each other's path. That would be the points of intersection. What is that intersection? So you have to devise a plan. So how do you do it? Well, at least in your mind, this is how it's going to be. So how do you do it? Well, you will lay down the equation for the ellipse. Actually, the orbit is an equation for an ellipse. This is the equation for a parabola, or the curve. This is the curve that describes the path of the comet. So this is basically solving the solution to a system of two equations. Your plan is to solve that system. Okay, so carry out the plan. Solve the system of equations and then review the solution. Do they match your expected answers? Those intersections or your solutions would have to lie in both curves. That is the meaning of intersection.